Good day, and welcome to Africa Teen Geek. This is a STEM digital school. If you have just joined into this classroom, this is a grade 12 physical sciences class. And today is the 23rd of July 2020. As I've mentioned before, today is our assessment day, our term 3 assessment day. Remember, guys, when we started during the week, we've been doing some revision for work, energy, and power, and for the Doppler effect because that has been our term 3 work. I hope that everybody has been following through on that and is good to go. So, getting our assessment started, I just want to remind you guys that you must write your name and class. Basically, this is on your paper sheet. Remember, guys, this is basically a self-test. You are writing questions without looking into the book. This is going to help you to know what you understand and what you do not understand. So this question paper does not consist of 10 questions, sorry. It's got about 3 questions, right? All your answers, questions on your answer book, and make sure that you number your questions correctly, okay? And leave one space between sub questions, for example, 2.1 and 2.2, and you may use a non-programmable calculator. Use appropriate mathematical instruments and show all your formulas. So make sure that you write neatly and legibly. Okay. So getting started, we're moving on. This is our first question, okay? So please, guys, make sure that you number them properly. And tomorrow, because tomorrow we're going to be doing corrections, and I will be asking you questions. So make sure that you number your stuff correctly. And these are exam question papers that I've taken to put as a class assessment for you guys. So it says the siren of a police car, which is traveling at a constant speed along a straight horizontal road, emits sound waves of constant frequency. Detector P is placed inside the police car, and detector Q is placed next to the road at a certain distance away from the car. The two cars' detectors record the changes in the air pressure readings caused by the sound waves emitted by the siren as a function of time. So the graph below were obtained from the recorded results. So graph A is the air pressure versus time by the detector P in the car. So graph B is the air pressure versus time recorded by the detector next to the road. Guys, please make sure you take your screenshots, okay? You take your screenshots of these questions so that you can go and time yourself and do your questions and answers. 45 minutes, guys. This test is out of 45. So it's 1 minute, one question. Okay. So this one says number 1.3, calculate the frequency of sound waves recorded by the detector. Remember, you need to know your source and your listener and the conditions. 1.4, use the information in the graphs to calculate the speed of the police car. Take the speed of sound in A as 340 meters per second. So that is the first question. So number 2 says block B of mass 2 kg is connected to block Q of mass 3 kg by a light inextensible string. Both blocks are on a plane inclined at an angle of 30 degrees to the horizontal. Block Q is pulled by a constant force N at an angle of 25 degrees at an incline. Block P moves on a rough section AB of the incline, while block Q moves on a frictionless section BC on an incline. See the figure below. So this is our figure below. So an average constant frictional force of 2.5 Newton acts on block P as it moves from A to B up the incline. So what does it say? So now we come to our questions on question 2.1. It says an average constant frictional force of 2.5 acts on block P as it moves from A to B up the incline. Number 2.1, state the Newton's second law in words. Okay. Number 2.2, draw a labeled free body diagram for block P. Number 2.3, calculate the magnitude of the acceleration of block P while block P is moving on section AB. And then number 2.4, if block P is now past point B, how will its acceleration compare to that calculated in question 2.2.3? Choose from greater than, smaller than, or equal to, and give a reason for your answer. Okay, so that is the end of question 2, and it counts 16 marks. So now we move to number question 3, right? Question 3 says stone A is thrown vertically upwards with a speed from the edge of the roof of a 40 meters high building, as shown on in the graph in the diagram below. Ignore the effect of friction of air friction. Take the ground as reference. 3.1. Define the term free fall. Okay. 3.2. Calculate the maximum height above the ground. Calculate the maximum height above the ground reached by stone A. Number 3.3. Calculate the magnitude and direction of the acceleration of a stone A at the maximum height. Okay, so stone B is dropped from rest from the edge of the roof after stone A was thrown upwards. So now it's continuing, right? So it says on 3.4, stone A passes stone B when the stones are 29.74 meters above the ground. Calculate the value of x. X could be a height, right? Oh no, the value of x is the time. Okay. So I hope you guys are good. Wish question 3 and you understand all the questions. You can, however, ask anything that you do not understand at the present moment. So this is a continuing question. So now they give you a question that says the graph of position versus time for part of the motion of both stones are shown below. Okay, so these are the position versus time. As you can see here, it's written position, there is written time. So they ask which of the labels A to H on the graph above represent each of the following. Okay, which one represents the time at which stone A has a positive velocity? 3.5.2, the maximum height reached by stone A. 3.5.3, the time when stone B was dropped. And 3.5.4, the height at which the stones pass each other. Okay, so I know this is tricky, but it's a test and we are testing your knowledge. So I want you guys to know all of these marks are, it's a total of 45 marks. Okay, so please guys, try and write these questions, and tomorrow we're going to come back and do the corrections for these questions. Okay. Thank you guys so much for joining into this classroom. I'm just going to show you guys again. This is our first question, and it goes all the way 1.2, 1.4. Then we move to question 2. This is question 2, and we've got 2.1 to 2.4, and that counts 16 marks. And then we move to number 3. This is number 3.1, then 3.2 to 3.4 on this slide, and 3.5 to 3.5.4. And question 3 counts a total of 18 marks. And all of these total a number of 45 marks. So guys, please make sure that you do these problems and you understand everything that is happening and test yourself. Tomorrow we're doing these corrections and make sure you follow the instructions. Guys, it's a test run. You guys are yet to write big papers. You're going to write your prelims and you're also going to write your final year exam. So these things, they require a lot of discipline, a lot of understanding that you guys need to acquire as you practice and study. Okay. Thank you guys so much. My name is Nonkululego Matondo. This was your term 3 assessment. I hope that everybody got the questions right and they have taken them, either you screen grab them or taken them via a phone. And please, guys, do them and we'll do the corrections tomorrow. Thank you guys so much and goodbye.